All right, we can go ahead and get started. So, fourth session of Solid Wednesdays. Going through today, we're going to be going through assembly modeling and drawings as well. We won't go too in depth in either one of those, just kind of mostly the basics. And hopefully, the session should be a little bit shorter. But as promised from last week, we're going to start off with reviewing sweeps, lofts, and boundary features. Brought my notes with me, so this time kind of be a little bit more straightforward about how to work with both or all three of those features, even though they are kind of more advanced. And that's the last feature that we should have to cover. So let me go ahead and you guys both got checked in. Cool. And I don't think I see anybody else joining us. All right, cool. So going on to, we're popping into SolidWorks now. Neat. Swap over to my display capture, which I finally got working. So now people joining on the live stream should be able to see everything, all the flyout menus and everything pop up too. Cool. So let's go ahead and open a part again. Hop in here. And to kind of go through kind of just a theoretical difference between all of them. So with a sweep feature, we can only have one kind of cross section, so that could be like a circle, an ellipse, a square, rectangle, but basically you can't make a circle become a square, you can't make a square become a circle, you can't add segments, remove segments from there. With a loft, you can do that. You can start to go circle to square, kind of like we were doing with the fan duct last week. And with a boundary, you can have a bunch of different profiles in between. It's just like a loft, except you can add in, way more control as to each profile with your boundary feature. And you can, so you can define constraints to any profile. You also have, kind of with those guide curves we were talking about, you have control of your curvature there, as well as on both your profiles or all the profiles that you're trying to go in between. So you have a lot of different options there. Boundary is basically the more powerful version of loft. And then just to kind of give some examples here, we'll go into a sweep feature real quick. So if you remember, start off with two sketches. One of them is going to be our profile. So we'll start with, let's do an ellipse this time around. So there's one radius, there's another. Let's do some arbitrary dimensions here just to give us something to work with. 50 millimeters, and then 100 or something like that. And then, let's see, probably set this center line to be vertical. Cool, added in that vertical constraint. Now this is a fully defined sketch, so I can use it for my part. And then I have to give it a path to go along. And one of the things that I realized that I did last week, which is why kind of that angled nozzle that we were trying to build that wasn't working. So when you're using like a circular feature or you're sweeping that along, and you give yourself a guide curve, you want that guide curve to actually intercept and to pierce through the actual sketch geometry. So this outside edge of the ellipse, not like its center point or some kind of other construction geometry. Always wanted to pretty much go through the geometry here. So with that center line, as we were trying to add another guide curve, it was trying to move that profile around and it couldn't because that center point was constrained. So so that's kind of that. And then we'll go through, so let's see, we're doing a sketch now on the front plane to do one of our paths. So usually I like to start these sketches somewhere off to the side. Let's do something weird. We'll make kind of like a bottle shape almost. Let's do, maybe like a vase. And then I'm going to click on that point. I'm going to move over to a different view so I can kind of see that ellipse. We'll make it pierce it, just like that. And then I should also add in, I'm going to right click on this and go normal to, so I can see it from the side. Add in a center line so I can do some kind of diameter dimensions, if you remember those from last week as well. And I'll go ahead and dimension that point there. 120 millimeters. This one will go 50. Up at the top, we'll make it do 40. Kind of tapers off. And then we'll also need to put a vertical dimension on this. So from the bottom all the way up, 150 millimeters. And if you remember when we talked about splines are inherently kind of underdefined. It's, you know, there's a lot of stuff that you can kind of drag around to make your part kind of look the way that you want it to look. And it's very hard to kind of actually go through and fully define a spline. So we'll just kind of do this just for illustration purposes. And we'll go ahead and exit out of that sketch. So now going for a swept boss. Remember, we're starting off with our sketch profile first in the blue box, and then our path up there. Let me just go through. Oh yeah, we still need, sorry, I should go back on this. Just trying to remember how they set this up here. 3 profile sketches, reference sketch. That doesn't make any sense. All right, let me just check something here real quick. Let's convert this entity over here. Sketch. Sketch. This is going up to the top and horizontal. Let me just double check something here. Okay, there's our path. Guide curve. Yeah, still doesn't like this. Oh, okay. Oh, that's why. So select that vertical line, guide curve there. Still does not like it. Why? Your profile number 2 can be solved. Original section of the sketch. All right. That's weird. See, I was doing something similar earlier and it was working fine, so I don't know what's going on. Let's see. Yes. Cool. Sketch. Construction. Vert. No. All right. Oh shoot. All right. So I am pretty stumped with sweeps myself. In general, the time that I would use a sweep is if I had to kind of, usually I just do it for like a constant cross section, like again, kind of what we were doing before. Yeah. That's really weird. Again, like I was doing this earlier with a similar kind of part. I'm just trying to copy what they got in my notes here. And I guess I'll show you guys here if you guys want to pass this book around. So just the page on the right there, if you're starting with this oval profile here, and then your centerline pathway that you're going up, or actually, let me check something here real quick. Wonder, I'm gonna hide that sketch, edit this one. Construction geometry. Yeah, I'm still stumped with sweeps, so we'll go through this. I don't know, maybe I'll have to like figure it out 100% and then make a little short video on it. But yeah, if you kind of saw in there, starting with intermediate profiles, or if you're starting with one profile in the paths, you want to use the sweep. If you're starting with intermediate profiles, like if I were to just go and make a bunch of cross sections and a bunch of ellipses, every 10 millimeters or so, I could use a loft or a boundary for those. So I guess let's just move right into assemblies, because that's really what we're here to talk about today. Right. So with assemblies, I kind of reviewed these earlier on. I'll pull up this grill assembly that I was using for a training session just to kind of go through and refresh your memory on the interface. So on the left here, instead of having features, we now have parts that we've dropped in. Within each of those parts, there's mates. So this is how we're connecting all the parts together. So there's a bunch of different kinds of mates. You can think of them kind of like sketch relations, in the sense that we're making things either share points or be parallel to each other, concentric, a bunch of other mates in there. And this one also has some sub-assemblies as well. So if we look at, I think it's this one here, anything with a little, this is just a part. If you kind of look at it there, thing with a part and another little blue box in there as well. That's a sub-assembly. So it has parts within the assembly as well. There's all your features to make that part happen. Put it all together, and then this is kind of what we were talking about last time when we were looking at the interface. So let's actually go through and make this mate, just to give you an example of how to do that. So we got this face here, and we want it to be sitting right on top of this one here. So this is our box frame. So we'll go ahead and click mate. We'll click on the bottom face here. You can also see that it goes transparent after that. So if you have two parts right on top of each other, it might be very hard to kind of get both those mates in place. So it'll go transparent so you can actually select stuff. You can kind of see I can select that frame now through the box itself. So it kind of helps to make sure you're selecting two different parts to mate together and not selecting the same part both times. Cool. So I clicked on both of those. SolidWorks does some thinking and thinks, all right, cool. Probably want a coincident mate here. You probably want these two things to be right on top of each other. And I do have a couple of other options, like I can make it parallel so it's floating up above it, perpendicular. I can give it a set distance and a set angle as well if I want to specify that. But again, in this case, I just want it to be sitting right on top of that frame. So we'll go ahead and hit green check mark there. And then you can see that it stays within this tool. So most of the time when you're building assemblies, it's going to take more than one mate to actually, kind of connect your parts together. So we'll go through, and so SolidWorks basically keeps it open for you, so you can keep adding in more and more mates until your until your assembly is fully defined. So next up, we have these bolt holes. That's kind of going to be our good way of locating where this part needs to be. So pick that one there. And I think it's this bolt hole here they're both going to want to connect to. And so we have this concentric mate that happens. That pops up. Again, SolidWorks kind of thinks probably this is what you want to do. And then we have this option here with concentric mates to lock the rotation. So if I don't lock the rotation, I'll go ahead and save this, exit out of the mate. I can now spin it around that frame section. Looks like that frame section also likes moving around too, so that might need some extra mates. But yeah, so I can spin this around, move it back and forth because that rotation isn't locked. In this case, I want to leave the rotation unlocked because I'm actually going to use another mate to define how this is angled around. But let's say that we're putting a wheel on our car. I could theoretically go and make one of the spokes vertical or something like that. But in reality, all I want to do is probably just lock the rotation of it. So the wheel's meant to rotate, but in order to define my assembly, I want to lock it and stop it from rotating, basically. So let's kind of swing this out again a little bit, and just so I can select that hole, I'm going to add another mate from that hole itself to that hole there. Cool. All happy. This box can no longer move. And you can kind of see this little tooltip pops up just for a little bit there. When I try to drag selected components fully defined, it cannot be moved. So that's awesome. That's exactly what we want to see. And then actually now this whole assembly is fully defined as well. You can see in the bottom here, none of the parts can move. Everything's all set. And this box, even though within the sub-assembly, it can probably open up and close. Let's see here. We can kind of take a look. What kind of mates does it have? Coincident. Coincident. All right, let's actually open up this sub-assembly. I want to take a look at this. Open part. Oh, nope. Open sub-assembly. There we go. Cool. So actually within the sub-assembly, that hinge isn't fully defined back there either, so we can fix that too. But within the sub-assembly, I can move this around however I want. I can go open and close, but if you notice when I go back to the full assembly, this is locked in place. It's going to have to rebuild here real quick. There's a little tooltip. Yes, rebuild, because I've changed things around. You can kind of see back here, this hinge is all wacky. I can go and fix that in a bit. But I can't move it in here, but I can move it within the sub-assembly. So that's part of designing within SolidWorks. It's called flexible and rigid sub-assemblies. Sometimes when you define things in a particular orientation within your sub-assembly, you make a configuration, you want it to stay like that. You're just positioning it kind of open within your sub-assembly, you plop it into a full assembly. It doesn't, basically SolidWorks doesn't fully transfer everything into the big assembly file in order to keep performance up. So the bigger your assembly, if it's trying to resolve all of those mates all at the same time, kind of just saves it as, basically treats it as a part now. It doesn't go through and try and recalculate all of those mates. Just like, all right, this is the geometry that it's set to in the part. I'm going to keep it that way, and then I'll let it, I'll do all the mates within the assembly. So it saves a little bit on performance. We do have the option to go through and make this assembly flexible, if I remember how to do that. Wait. I'd have to take a peek at that again. But in general, shouldn't really need to do that too much if we were going through and actually properly defining all of our sub-assemblies here. So if we go through, probably fix these real quick. So this thing can kind of move around a bunch, add in some mates. One cool thing, so kind of going into that mate toolbar and trying to figure everything out on the side here, SolidWorks likes giving you tooltips. So if I control click on this, pops up with some mates that I can just plop in right from the viewfinder. I don't actually have to go to the mate command. It pre-highlighted there. You can kind of see, go there and there. Pre-highlighted concentric, because that's the one that it would have done if I was in the mate toolbar. And there we go. Now I have that concentrically defined to there. And do same thing with this one. Move that out of the way. Make those two concentric as well. And then now I think that should be pretty well defined. So I can open and close. But see, this can happen too. So within SolidWorks, it does actually have collision detection. So it can tell when these parts are hitting each other, but it doesn't do that dynamically. So it doesn't automatically kind of keep calculating that all the time. I actually have to go here, evaluate, and makes that fun noise. Now you can see all the areas where it's interfering. So in order to solve that, one of the things we can do is do one of the more advanced mates. So let's go back into that mate toolbar, kind of go through, we've talked about coincident, parallel, perpendicular, tangent, concentric. Those are all pretty straightforward, just like we did before. We can add dimensions as well. In advanced mates, this is kind of where the bulk of stuff starts to come in. So we have profile center, so the center of like a circle would be put inside the center of a square. Symmetric, width mates we'll talk about a little bit. Actually what we need here is, I think, an angle mate with a minimum and a maximum mate. So this is what we're looking for here. So we want two mates here. We want to define the angle between these two faces. So we're going to set our minimum angle down here to be 0 degrees. And then our maximum, let's say we only want this to open 100 degrees. Cool. So we'll do that. Click on that. And now I can still move this around and go down to 0. Can open up to 100. So this is a way that you can build in a little bit of functionality. Like if you're showing this part to somebody else and say, hey, this is how it can operate. Again, it's not entirely defined. There's kind of an angle that it goes, between. You can still, your assembly is still kind of flexible. It moves around. But now it's not you're not gonna go spin a wheel or press on a pedal and it's gonna go all the way through the car. You're gonna open it up and it's gonna stay open. It's not gonna go past like a mechanical stop, and same thing with closing as well. And now, if you remember that little interference detection thing, there's just a tiny interference over here in our hinge, and that just looks like, what is that? 2.25 cubic millimeters of interference. So that's really nothing to worry about at all. It's just, the parts kind of rubbing up against each other there based on how they were modeled. Yeah, so that's one of the advanced mates. You can kind of define, you can also do the same thing for distance. Like if you're trying to make sure that these two parts, stay a certain distance apart. Like a brake caliper, for example, that can move. You want to say, okay, this can go within, right up against the disc, or maybe 2 or 3 millimeters away from the disc. And you can build in functionality that way. Again, I can kind of close this. What's up? Mm-hmm.
Like that last one, you said 0,
mm-hmm.
So that when it's fully closed, it's 0.
Yep.
How does SolidWorks then? Is it off of whatever plane you tell, or how does it determine?
Yeah. So when I went in, let's see, where was that mate that I added? Limit angle, edit feature. So what I did when I selected those two, was I selected 2 faces, and it's just the angle between those faces as it goes up and down. And down here you can kind of see mate alignment. You can flip itself around and kind of do the other angle between the faces. But we kind of want it to be like that there. So yeah, it's just the angle as I open it up. Selected this face here and that face down here. Yep. So from the side view, it's that angle. Yeah, I could also do like an angle between these 2 hinges, or other geometry as well. And yeah, it all, like when you're adding in your mates, you really want to. That's one of the tough parts, is you really want to figure out and pick stuff to mate that makes sense. Like you don't want to be mating just this random tiny little point on your part. You actually, most of the time you want to select like a face or an edge of a part to mate to. You don't just want to be going off of this point here and this point here and making sure they're coincident. You want face on face or edge on edge. Those kind of mates are usually preferred. So let's see if I can figure out a good way to show you guys a width mate here. I wonder what kind of mates does this thing have? So coincident on there. Those 2 are coincident as well. Interesting. All right. Actually, hold on. I want to save the changes, rebuild and save. And it's going back into the assembly. Now you can see, again, grill hand, or the grill top is closed, because that's how it was built in the sub-assembly. Cool. So let's go ahead and make some parts here real quick. I'm just going to make some super simple parts just so I can show some of the more advanced mates. Go through, let's do something that looks like upside down U. Or actually, I'll do really what I should have done. Let me just recreate this real quick. Do there. Kind of messy design here, but we're going to go ahead and click on those 2, make them a construction line. Basically what I'm going to do here is I'm going to make a chain, or a link of a chain or something similar to that. Coincident. Control do 30 millimeters wide. We'll make this 25. Make the distance between these two be 10 millimeters. Oh, hold on. Distance here, 10 millimeters as well. Make this cool, that should work. I'm going to select all of those except for that one and mirror it over. Cool. Go through and extrude it. 25 midplane. And then make a sketch of a slot. I don't want to add in these dimensions yet. Cool. And that'll make 15. So if you guys remember last time when we did So last time we're kind of talking about the direct editing. Basically what I'm doing here is first sketch that I made was a kind of top view of my chain link, and this is my side view. So it's kind of rounded out on both edges. Got those circles there. I used the slot feature because that gave me a center line to go off of so I could place my holes concentric to that radius on the outside. And then now I'm just extruding. You can kind of see I have a through all. I can just make a body that's the exact same size as everything else. Clearing merge result so that I have two separate bodies. And then I'm going to go ahead and select both of those, combine them, common. I should just click on here. Cool. And then that gives me my little chain link here. So save this real quick. Then SolidWorks, there we go. Go ahead and make an assembly from this part, just an assembly template. Cool. What SolidWorks does, click on that, click the check mark, and first part that I place within my assembly is always going to be centered around the origin. You can see it's fully defined, the origin's merged, I can't move this around, it's fixed to that origin. So that's something to kind of keep in mind. When we're building our full car assembly, for example, we'll want to put the frame in first, have that be the fixed thing that everything bolts up to, and then go from there. You don't want to just put in a wheel first and then try to orient your chassis around it. It makes it kind of whack. All right, so what I want to do now is add another chain link that kind of connects here. So I'll go ahead and go up to my assembly, insert components. In here, SolidWorks is going to show you all the parts that you have open right now. So if you're trying to add in a part that you don't already have open within SolidWorks, you'll browse for it. We already have this part in here. And then I can add that part in here. So I'll go ahead and click that down. Now it's just floating in space. I can move this around. I can rotate it. If it was kind of pinned here, I'd be able to rotate it. But right now it's just floating around. Our assembly is underdefined as well. So we'll go ahead and start making some mates. Oh, those shadows. Okay, cool. I thought I had added in another part there. So we'll go ahead and I'll just use this mate toolbar here just to show you guys a few things. So we'll go there, concentric mate. And I have that option to lock rotation. I'm going to leave that off for now. Green check mark to finish that mate. And I'll finish that off there. So again, now I can kind of rotate this part however I want, move it around, interfering, it kind of interferes there. And then if you notice, when I designed this chain link, one of the sides is, or so this gap here is bigger than the part that's going into the gap. And I want to mate it so that this part is in the middle. This part that kind of sticks in is in the middle of the forked part of that chain. So there's a special mate for that. It's in the advanced mates. It's called the width mate. So you have your width sections and your tab sections. So you can think about the width as what you're kind of trying to constrain between, and the tab is the thing that's going into it. So I'll select 2 faces for my width, and then it automatically goes to the tab. So there's those 2 faces, and now it centers that in the middle. I can also change that around. It can be free, so I can kind of move around within that width, left to right. It can be a dimension. I can also do a percent. So right now it's 50%. I can lower that down. Let's see, make it like 25%, and you can see now it's 25% towards that face. You can also flip it around if I want to dimension 25% from the other side. But in this case, or most of the time, you'll probably just want it centered, just in the middle, or you might have a specific dimension that you want away from something else, or you might just want it to be kind of free to move around within there. So you have all those options there. And now click the green check mark. See here, it's still underdefined. So if I go and move it around, it's just this rotation that's defined. You can see kind of like we were using with that grill handle before, up and down. So we'll go back into our mates. Advanced mate. Let me just double check. Yeah, so we want to go into advanced mates, give ourselves an angle again between these 2 faces. Flip that dimension, I think. No, we'll just go. Cool, there we go. So between the mate alignment and the flipping of the dimension, you can kind of position your part to roughly where it should be. So this is 30 degrees here is what it's measuring. So I want my minimum to be 0. I want those things to be able to go right up against each other. And then I want this to be able to move all the way out to 180 degrees. So add that in, click. Now it's fully defined. And in this case, what fully defined means is not that, not like in a sketch where we can still move around dangling entities, but that the motion of every single part is defined with stop. So it can't move. So in this case, it has a fixed amount of rotation that it can actually do instead of the full 360. And then, let's say that I wanted to add another one of these chain links. So I can go back through, click Insert Components, add all the mates again. I can go through that process a bunch of times, but if you think about it, actually creating a full chain, it's going to take a while. I'll show you 2 tools here real quick. First one is a really cool one that I learned fairly recently. If I just want to add in another one of the same part, just click Control or hold Control, click and drag the part, and it just makes a copy of it. So again, if we're adding in like 2 or 3 wheels, on top of the one that's already in the car model, just click and drag. And then add in your mates. You're probably going to be mating 2 different things. But in this case, we also have the option to do copy with mates. So if I right click on this part, click copy with mates, gives me, all right, cool. So this is the part that I want to copy. Not clicking the green check mark, I'm clicking this little arrow up here. And then it shows you the 3 mates that you have. So your concentric shows you kind of what it's mating off of. Cool, so I want it to make concentric to there. Width, I'm going to have to give it the tabs. So it's those 2. And then the angle, I have to give it that pink face there. So it's going to be right there. Cool. So you can see this text box here is green now. So, and then I can also go in and add another. So kind of get in the groove of things. Just click that one. Kind of shows me here. Need to click that face and that face, and then I have to give it that limit angle, and then I can keep going through and adding in a bunch of them. And then see, now I can move this chain around a bunch more. You guys follow that? Need me to slow it down? No? Good, cool. So that one was a super cool tool that I learned when I was taking ME250 here. I was building, our midterm was to build a desk, and I was trying to add in every single fastener, and I had this repeating bracket all over, tired of dragging it in and making the mates again. So that's super handy. It kind of, it still uses, when you're dragging in this new part, it takes all the things that you'd pre-selected, like if you remember on this width mate, we selected these two parts on the part that we added in, and you just have to click on the things that you're mating to. You don't have to re-click those same faces again. And for the concentric mate, I only had to click just the part that it's being concentric to. It's still thinking about using that same exact part. Yeah. Let's go ahead. Let's actually do that real quick. So copy with mates. There it is. All three. Yes. Or let me do those two. It's telling me it's underdefined. So theoretically, if I use like a fixed mate, it would let me do, or like a, not that limit angle. So let's go through and change that up real quick. Mates, limit angle, edit. I will just make it a normal angle. And I'll make it like 60 degrees or something. Cool. And then go through and change the other one up too. Cool. All right, let's try that. Underdefined still. That's really weird, because I cannot move any of these around. Maybe not. Maybe I can only do one at a time. But yeah, you can kind of see there's that start concentric, there's the end that I need to select. It highlights everything for me that I need to pick out. Click. So I'm pretty sure that it's possible to do multiple bodies copying with mates. I just have to kind of see why it doesn't like this particular one. A good chance is it might be that width mate. Between those two, I think SolidWorks might not like the more advanced mates and copying them over. But yeah, we can look into that and play around with it a little bit more too. Cool. All right, so that's the width mate. Let me just take a peek here, see what else we have. Linear coupler. So there's a couple of mechanical mates that I won't really give you examples on. I'll just kind of show you that there's that they're there. So a cam, if you think about a cam in an engine, it moves around and it pushes down on something. Basically, what you'd do is you'd have a camshaft added in. You'd select the face of the cam and the other thing that needs to follow it, like your valve. And then as you move it around, it'll just stay coincident to that face basically, and it'll move up and down with that cam. You also have the option to do kind of slots, so have something that slides back and forth. You just select that slot feature, just rounded out edge. Hinge is another one of those kind of wacky ones. Basically the angle limit mate and your concentric in one, which is kind of cool. So maybe we could actually even do that here, but yeah, let's try that out actually. Drag in a new part. This thing doesn't have any mates. We'll do a hinge mate here real quick, just to test it out. Hinge, concentric selections. And then coincident selections. I think it's gonna be those two. Cool. So now you can see I can just move that around, makes it a hinge. And then if I go back into this, so as you start to build your mates down here, you're gonna start to see a history of them. You can always click into them to go back in and edit them. I can change my angle limit. So I'll specify my selection of what I want the angle to be. Minimum of 0. And then like a maximum of 60. Maybe I can do like -60. Cool. So now you can see I can move up to a certain point and then back down.
With that one, doesn't it make it not set
Yeah, yeah, exactly. So good catch there. So with the mate there, you have a coincident selection. So that might be something. So SolidWorks has a feature where you can go in and actually request features to be added. That might be a good thing to kind of submit and be like, hey, this would be really neat. And yeah. But yeah, so you also have gears. So in this case, you have 2 gears selected. You pick out their diameters, the ratio, and then as you spin one, the other one will spin at that ratio. Same with the rack and pinion. Have a gear spinning around, and it'll push something back and forth linearly. And you can define that different ways based on just the pitch diameter or the travel of the rack per revolution. So if I spin the gear once, how far does the rack move? Same thing with a screw. How many times it takes me to turn that screw for it to travel a millimeter. Good for if we're defining for building a vise, for example. Want to turn that handle, see the thing actually move with the handle or with the handle turning. And then a universal joint mate as well. That just lets you spin, transmit power at various different angles. So, and these things you don't actually, for the gear mate, you don't actually have to actually draw in gears with specific teeth. You can draw in 2 circular things that are completely different shapes or not even touching, and then you define them based on a certain ratio. There's also, within that gear mate, I'm pretty sure, or no, that's another feature within SolidWorks. You can actually build belt systems natively within SolidWorks, and you have all your pulleys that you select. It calculates a belt for you. You can switch which side of your pulley your belt's on, gives you the length of it. You can add intentioners and that kind of stuff, which is super cool. But kind of that same principle. You're defining things based on certain ratios, certain diameters. So that's what it usually defaults to, is just the diameter of your part for your ratio, but you can always override it. And then with your advanced mates, the path mate is one that I've found very little use for, but it's kind of cool. So if you want to have something move in a specific pattern within your assembly, you just draw that pattern out in a sketch. Let's say that I want my wheel to travel up and over like a speed bump or something like that. Draw that path that goes up and over. And then I haven't messed around with this linear coupler too much. For me, really the ones that I use a lot are the standard mates, and then the width mate I use a bunch because I'm always designing parts. If I'm designing parts for 3D printing, I'm going to print them out separately. The plastic isn't going to be very true to dimension, so I always add in like a 0.2 or 0.3 millimeter clearance. And so when I'm building my assemblies, I'll use that width mate to make sure that clearance stays between the parts, that are not right on top of each other. Yeah. So that's mates. Mates are pretty much the biggest thing within assemblies. I'm going to be spending a fair bit of time kind of adding in. Once we start to build that full car model, you're going to drag the chassis in. You're going to start adding suspension points and pulling them into there, or suspension arms. You're going to have the points. You're going to be able to move around in a bunch of different directions. Then you might define them to be between a certain angle, so you don't have your wheel up on top of the car. Right. Yeah, so, and then other than that, there's a couple of neat tools within assemblies themselves. So we have that interference detection that we kind of talked about before. It's a good way to keep track of your mates and make sure that you didn't accidentally put in a part that's interfering with another one or intersecting one. And then there's also a clearance. So interference only detects if the part is sharing physical space with something else. But in the physical world, we actually like to have a little bit of space between parts so we can move stuff, kind of assemble things, have stuff slide past each other. So you can also do a clearance verification. Between these two, we're going to say that we need a clearance of 0.1 millimeters. And it's going to calculate, and it's going to show me, let's see, clearance there. I thought it would highlight them for me, but it just shows me that these two parts are coincident or interfering. They don't have that clearance there. If I go through and I run this a bunch of times as I'm building my full car model, and this one clearance keeps popping up and I know it's okay, I can click ignore, and then next time that I calculate, clearances between everything, it's just not going to pop up there. It's saying no clearances. Cool. Other than that, if I were to go into this part, for example, and give it a material, so let's say this is made out of steel. Save that. Switch over to that. It's going to rebuild everything. Cool. Wonder why. What is it upset about? All right, regardless, I just wanted to show you guys that there's mass properties within here. Come on. All right, there we go. All right, so I can kind of see, with all these different parts, SolidWorks can calculate the center of gravity and the mass of everything all together. So this is really handy kind of when we're doing suspension design. Or making sure that we can pass the tilt test, make sure that our car's center of gravity is low enough that when we tilt it up, the center of gravity isn't gonna go past the wheels. So it gives me all the values that I need, shows me a little triad of where the center of gravity is. I can also create a center of mass feature. So if I click on that and close out of here, there is this actual feature right here. Wonder if it's just not showing because of this. Cool. There we go. So now I can always see, as I'm adding stuff into the assembly, always going to be in there every time I rebuild. And then I can also measure off of it. I can do a couple of things with it. It's a feature. I can do anything that I could do with a normal feature, to an extent. It's basically just a point in space that's defined for me. Other than that, I can measure stuff, the distance between points in assemblies. If you're trying to figure out how much space do I have to actually, can I stick a motor in there? Can I run wires past it? How much space is there around my driver's legs? If, like, we have a driver model within our chassis or something else. So that's kind of all there is that I think I had to talk about with assemblies. Mates is the biggest thing. Adding in components and copying them over with mates that you don't have to keep dragging in the same component over and over and going through and remembering, all right, which mates did I do? What did I mate off of? This way they're all built the same way. And then within an assembly, I can also make parts. It's a little bit more advanced. I won't go into that quite yet, I don't think. But a couple of other nice things that we can do is we can make our own reference geometry. So if we have our center of or our origin on our chassis, we actually want to make like a plane that's the ground to measure stuff off of. We can go off of that and make a new plane, add that in there, and then measure from there. We can do the same thing with like coordinate systems. For suspension, one of the coordinate systems we use is centered around the rear axle. And so if the chassis coordinate system is origin at the main roll hoop or something like that, I can add in same thing. I can add in that coordinate system, put the two rear wheels in, draw a line between them, make an axis, and then put a coordinate system right there, right on the midpoint of that axis. Cool. Any questions about assemblies? For now, no. Cool. Let's take a short, 3-minute break, and then we'll talk about drawings for a bit. I'm going to look through my notes a little bit more because this sweep thing is bugging me a bunch. But yeah, let's take a short break, and we'll resume at 1:56. All right, let's get back into it then. Figured it out. So with sweeps, basically what I did here is the exact same thing I was doing earlier, except instead of creating the profile first, I made the path and the guide curves first. And I guess kind of what this boils down to is making sure that your path is being pierced, or sorry, your profile is being pierced by the path and not your path being pierced by the profile. That kind of makes sense. So I went ahead and made the path that I wanted to go through, made that one there, or that guide curve there, and this guide curve here, and then I went and drew my ellipse that I wanted to draw through. And then on this sketch itself, I'm defining this by the path instead of the other way around. So click on this. See, there's that pierce relation. I'm piercing that point on the ellipse to this path instead of what I was doing before, where I was piercing the end point of this path to somewhere along the ellipse. So now we can go through. I didn't make any changes there, so I can go through and do a swept boss base. There's my profile that I select. There's the path I'm going along. And then these guide curves. So this one goes along that plane, so I actually don't have to make a guide curve on this side, just that one there. And then I can click on this other one as well to get my curve in the other direction. So glad I finally figured that one out. So make your paths and your guide curves, so the stuff that's defining kind of what it's going to look like, and then your cross section afterwards. Make your relations to pierce that geometry there. And just to kind of show you, I'll just redo this sketch real quick. So top plane, make a new sketch, drop in that ellipse, 1, 2. I'm going to look off to the side, grab that point, pierce it to the path, grab this other point, pierce it to the guide curve, and then grab this last point, pierce it to the guide curve. So again, the guide curve is piercing the profile instead of before where the profile was piercing the guide curve. So going through there, same thing with that boss. Picking it up through that path, clicking on our guide curves, 1 and 2. Then click on OK. Have my part nice and smooth. So, all right, moving back on to drawings now. So drawings are a little bit antiquated, I guess I'll put it that way. The way that things are moving now, people are moving towards what we call 3D PDFs. So it's a step above drawings. Instead of just having 2D projections, we can actually see the part in 3D. Somebody can open up it's a PDF file. You open it up on Adobe Acrobat. You can move your part around within it, which is super cool. You also have predefined views. And those predefined views show you your dimensions, certain cutouts if you need a cutout or anything like that. So you can see all that stuff within your 3D PDF. But drawings are still a very useful way of communicating part information. So super simple stuff, like just one of these chain link dimensions. We're going to go ahead and go back to this part itself. And you can make different drawings for both assemblies and for parts themselves. So we're going to go ahead and just make a part drawing first. So I'll open up this chain link, click Make Drawing from Part, standard drawing template. You can have different kinds of drawing templates as well, different sizes, different text in this lower right-hand corner. I'm trying to develop some for the team to use, kind of have those up eventually. But in general, you're going to open up a drawing. I'm going to pick what size, pick a letter size piece of paper here. And then it's going to, since I started with that part and went to this drawing, on the right-hand side, it's going to give me all the different views that I can drop in. So I'm going to ignore that for now. I'm just going to go ahead and click Standard 3 Model, or Standard 3 View. Click the green check mark, and it's just going to plop that right in for me. So I have top view of my chain link here, or front view, and then my right-hand view. So that's, again, the standard kind of stuff that you're going to see. And then let's say that I wanted to see the backside of this. So right now I'm looking at the front, just from this side. I want to see the other side, so I'm going to click projected view here. I'm going to click on the view that I want to project from and move it over. It just kind of adds in, rotates it by 90 degrees, plops in that view off to the right there, and you can see, if I go to start to drag this around, it's going to show me that little center line of, hey, this is reference to that view over there, this one's reference to that one, and so on and so forth. I can also do a projected third angle. So because this is a very common view that a lot of people want to have on their drawings, you kind of want to be able to see it, what it looks like in 3D, not just from each side. If you instead of going right off to the side, kind of up diagonally, it'll bring that up for you. And also if you want to get rid of this little constraint line, so most of the time I don't want to just put it right in the middle here, I want to put it up here in this corner, but it's trying to get constrained along this 45 degree, hit the control key, and it breaks that constraint. So this is very useful for that an isometric view right there. Within each of these drawing views, I can change what each of them look like. So this one, a lot of people will often do, click on the view itself, gives me the properties here, can change the display style. And often you'll do something like this, where you have it shaded, especially if you have an assembly, a lot of different parts, different color, color coding that you might do, plop it up there. And then usually what I want to do, the reason that I'm making a drawing is because I'm either sending this off to a manufacturer or I want to detail some stuff. I'm going to go ahead and delete this drawing view so we can have a little bit more space to do stuff. There we go. Move that around. Cool. So I want to add some dimensions. I can do them just like I would in a normal sketch with Smart Dimension. Maybe I want the width of that part to be dropped in. Probably want this whole call out. Plop it up here. I want the outside radius of this. Want the width between these two. And I can go on keep adding in these dimensions and placing them where I want. One of the nice things SolidWorks will do for you is, I need to add in a bunch of dimensions to this part, right? So I'm going to go through, click those two, and you can see this little tooltip that pops up right next to my mouse. It gives me the option to, kind of right there without moving my mouse too far, either place this at the top of this drawing view or at the bottom. And you can see that it starts to move other dimensions out of the way. So it's moving that 30 millimeter dimension out of the way if I try to place it below, or I can place it up top. Same thing here. If I just want to draw this line, immediately pops up, tells me do I want this left or right, put it on the right side. Same thing there. Want a dimension between those two, put it up top. Just like that, without putting in a lot of mouse movements, you can plop all these dimensions in super, super quickly, which is really, really nice. But we'll go ahead and delete these to show you an even faster way to bring in your dimensions. And that is with this Model Items button. So I can click on a certain view to bring in associated dimensions from when I model this. I'm going to go ahead and just select all three of them. It's going to bring the source from the entire model. So basically going to plop in all of the dimensions. Oh, hold on. Let's try that again. I might not like the way that I designed this model too. So I'm just going to do that entire model. It's going to give me dimensions, not marked for drawing as well. They're not parallel to the drawing views. Let's see. Try this one. Nope. All right, doesn't like this part. I'll see if I can open up another one here from my SolidWorks training files, SolidWorks drawings. It's probably going to be a good one to do. This whole tables. All right, I'll add in a standard view there. Oh, that's weird. All right, so let's see if I can add in the model items for this. There we go. Cool. So this was just, you saw it was like a rectangular cube there. Go ahead and move this over off to the side here. Add in a projected view, so you can kind of see, super simple part. But with that part, it came and brought in just the dimensions that I needed. to make this part here. So 100 millimeters wide, 25 millimeters tall. If I dragged in, I want to see if I can remember how to do this, because there is a way to just, with a keyboard shortcut to bring in a projected view, but looking at it from the top, annotation, model items, bring that in, check. And you can see that it only brought in this 75 millimeter one. So it already knows that this 100 millimeter dimension that would define the top here as well is already somewhere else within my drawing. So it's not going to go through and actually duplicate any of these. It's just going to drop in just the extra dimensions that you need to define your model. So again, with just these 2 button pushes, we added in all the dimensions we need to make this super simple part, but you can see how it can be fairly powerful for a more complicated part. Just drop in all of your holes, fillet dimensions, the width of all your parts, all that kind of stuff. So that's kind of where we're at there. And then let's kind of move back over to our chain link example as well. So with the chain link, we have those smart dimensions that we can add in. Just add in a couple more of those here just so we can mess around with them. Place that at the bottom, this one at the top. Let's say that I wanted to take this 30 millimeter dimension, and instead of seeing it on this top view here, I want to see it down here. So what I'm going to do is I'm going to click on that dimension, click drag with control, and then, hold on. Add that back in. Cool. I'm pretty sure just click drag over to take a peek. So basically what you can do is you can move these between different drawing views without redrawing them. Have to see, maybe it's shift. Yeah, there you go, it's shift, not control. So by clicking and holding shift, move between drawing views. So if, again, you plop in a bunch of model items from one of your views, it's not going to be, it might get super cluttered up here, so you might just move stuff over to another one. Another thing that you can do, I'll talk about here real quick. So smart dimension, I have these 2 holes that are both the same diameter. So I'll say this one, actually, you know what I'll do here real quick. I'll place this up here. On the left here, I have a lot of control over what I do with these dimensions and annotations. So up here it just says, here's your diameter, here's the value of that dimension itself, and at the bottom I can write in x2. So there's 2 of them. So I can actually go in and actually modify what it says up here. And like here, radius 120, I can say, it's going to be 120 everywhere where there's a radius like this. So TYP, typical. So this radius is the same here as it is over there. And so I can, just like that, I can add in, if I had a bunch of holes, I could say, hey, there's 4 holes, or M6, drill then tap. I can add in notes like that. I can just drop in a note as well if I just want to say, drill undersize or something like that. I don't know, undersize. And then I'll just put that over here. So I can drop in either manufacturing stuff or stuff to point out to people as they're looking at the super complicated drawing, trying to figure out, okay, this is what I need to do, or hey, don't machine these parts here, just worry about the outside dimensions or whatever else. So there's a bunch of different things that I can do in terms of adding in notes. It's fairly free form. The big thing to kind of mention with drawings as well is this block of table down here. So this is something that we can change and kind of add in the little drawing title. This automatically populates with your file name, but you can change that as well. Revisions, who drew it, checked it, who engineered, or engineer who approved it, and then the manufacturer who approved it too. So this is something we're going to be making use of. So SolidWorks PDM actually can fill in these for you when we go through and you submit a part to have your subsystem lead review it. Their name's probably going to go somewhere right here. Then general specifications, your material, the finish of it, and then just this proprietary confidential generic block there. So have This is going to be on a lot of drawings. It's fairly standard. Gives information about what this part is, who it belongs to, who's signing off on it, what's it for, what's happening. There's your comments, geometric tolerance, saying what's happening next to this part, and so on and so forth. But for the most part, drawings are pretty straightforward. Like I said, we're going to try to move to 3D PDFs as soon as I can figure out how to make those work. And that's mostly going to be a project for myself for summer. But drawings in the meantime, you're going to go down to the machine shop. Most going to be using mills, 2-dimensional or 2.5 dimensions. Basically going to be looking at it from face views. You're not going to need to see too much in 3D. Draw your stuff out. Do it in, if this is all in millimeters right now, if I'm going down to the machine shop, want everything in inches, right down here, can switch it over. It does all the unit conversions for me. And that way, when I'm looking for an end mill or reading the DROs down there, I know what I need to do. Other than that, there's a couple of other more advanced drawing tools, which we'll get into once we start preparing actual drawings. But another one of the cool things is we can do like section views. If I wanted to cut this part in half and see what it looked like, this one's going to be pretty boring to do, but cut it right in half, and it's just going to be a normal section. I'm going to pull it out. You can see it shades in the part that's cut through, and this is just the part that it's looking at there. It shows you section AA goes between the two A's, an imaginary line that cuts through all the way. You also have a detail view. So if I wanted to, kind of just really hone in on this bit there, drop it right there. Detail B, it's just showing me that corner super close up. It's at a 2:1 scale. If that corner had some super nice detail or like a specific radius, or like a pattern on that radius, like on the edge of a cabinet or some trim molding or something like that, you might do a detail view of that just so you can see exactly what it looks like on that corner. Kind of scaled back, it would look, everything might kind of blend together. So that kind of covers the basics of drawings, at least for parts. So let's go ahead and look at an assembly drawing. So go to this assembly here, make drawing from assembly, save and insert. I'll just drop that in there. Cool. Drawing. Pick a bigger one this time. And then I'll drop in a left view. Once I drop in one of these, it automatically asks me if I want to kind of add in some projected views. And then I'll drag and drop that over there. Cool. So this is a fairly simple assembly. We only have one part repeating itself, but I'll still show kind of some of the basic tools that you'll want to use. We'll add in over here on tables. Bill of materials is usually one that you're going to want to add in pretty much every single time you use. Just has you select the drawing view. So from there, you have some options here for your template. Top level parts only and indented just kind of formats your BOM in a couple of different ways. Top level shows you, like if you remember in that grill, it's just going to show you the sub-assemblies. It's not going to go through in detail every single part within that, the top of that grill. It'll just say, top of grill box sub-assembly. Parts only will actually go through and list every single part, and then indented will take that sub-assembly, list it, and then all the parts within it, kind of on the next line indented down. But here, our bill of materials is pretty small. I'll zoom in on it just to show you what it shows. Item number 1 is a chain link, and there's 5 of them. If I wanted to add in a description here, I can just pop in, double click, and then start writing stuff in. But otherwise, let's say that this bill of materials is 15 or 20 parts long, and I want to actually go through and detail what each of these parts is. For that, I use balloons. So I'll click on that balloon tool there, click on just an edge of the part that I'm trying to detail and mark out. You can see it plops in that number 1. And that number follows the bill of materials table. So you can see up here at the top this little message, if you need to order balloons sequentially, a bill of materials is required. Again, you have a bunch of different parts. I guess my roll cage actually would be a great example for this. Let me pull that up. Cage rev D, open that up. and open drawing. Yeah, here we go. Cool. So this is the roll cage that I designed for my Porsche 944. And you can see each of these individual tubes has its own label or its own balloon. One good thing to do when you're actually doing all these balloons is to make sure that it goes to the edge there. So you can see this arrow pointing to the edge of that specific part. And you always want it to be the edge closest to the balloon. Like, I don't want this balloon to go and this arrow to point to this edge and have it cross over. You really want it to be on the edge. That's just some good design practice. But in general, this just shows me all of the different individual tubes that make up the cage. And then when I go over here, it's going to show me, all right, item number 1. Cool, there it is. That's my main roll hoop. Since this was built with weldments, which we'll talk about next week, it shows me the length of the tube that I need to cut in order to make that specific part. And then same thing with this backstay here. So there's part number 2 right there. Part number 3 is there as well. And each of these has just one of each, except for this one. So part number 16, let's see if I can find it here. So it's just this tiny little piece down here. It's the same on both the driver's side and the passenger side. So SolidWorks will go through and realize, okay, hey, I have the same part, group them together. So like with that chain link example, we had 5 of them, grouped it all together into one list. But if a part's a little bit different, it'll go ahead and give it its own line item in the bill of materials. So like this passenger side and driver side backstays here, they are different parts within the assembly. Or different parts within the bill of materials. And then also you can see I have these mounting feet down here. I detail them here, part 26 and 27. I can add, so again, kind of going back to the duplicate parts. So there's 4 of these. I can detail each and every single one of them, or in this case, I just chose to do 2. So I wanted to show that at the front, there's this mounting foot, and it's also the same mounting foot that's used for the main roll hoop, but on the rear, it's a different mounting foot. So yeah, just going through, shows me all the different lengths of all those tubes, quantities of everything, and you know, kind of, if I click on one of these balloons, it also shows me which edge it's oriented off of. Yeah, so that's kind of that for bill of materials. Other than that, you're probably not going to use drawings too much. You'll kind of, within an assembly, you really want to kind of highlight, all right, here's all the different parts, here's how they fit together. If you have fasteners, they'll all get listed in the bill of materials as well. And then you can kind of point to different things. You can color code things. So like this, if I had a bunch of different colors, I'd probably do shaded with edges. Like if each of these tubes were colored differently, like our chassis that we use, or the little photo that we use for our chassis is a good example too. Let's see, this one here, you can see all the different chassis tubes. If I dropped in that model here, it would highlight all of the different ones. Yeah, I think that's really it. Yeah, that's really all that there is to know in terms of drawing. I mean, there's way more stuff that you can do. Like you can do all these different views at different angles onto your part. For the most part, as we're going to be moving to 3D PDFs, we'll just use drawing views for now for like simple parts that we go down to the machine shop, print out a piece of paper so you don't have to keep pulling up on your phone the PDF and stuff like that. Yeah, you guys have any questions about drawings, assemblies, anything else that we covered today? Cool, should be pretty straightforward then. And then, like you were saying before, or at the general meeting, kind of having more kind of stuff to work on. I brought in a couple of small parts. If you guys want to kind of spend some time in the lab, I can show you the part and have you model it. It's a kind of a simple, kind of a complex part in a couple of different ways. So I want to see the approaches that you guys take to kind of start setting the part up, and once you start getting to the more complicated sections, kind of what you or how you start to approach it. But if you're interested, just drop by, let me know. I'll be around for a good chunk of the rest of the day. Let me just pull up my agenda here real quick just to make sure I'm not missing anything. So looks like I covered mates, constraining them, copying with mates, the measuring stuff. Oh, the last thing that I wanted to talk about with assemblies is something called pack and go. So let's see if I can open up that grill assembly again. File, open, recent, full grill assembly. So with this grill, there's again a bunch of different parts. I don't know where all these parts are located on my server, or wherever else on my hard drive. I might have pulled some switch from another part, or some downloads folder somewhere, and then my documents another one, and then a picture for a sticker somewhere else. But I want to send this part out to somebody else, so my subsystem lead can take a look at it, or I could send this out to a manufacturer. I want to collect all those files together so that he's not, whoever's going to be looking at this isn't missing out on a key part. And it can take a long time to kind of figure out where all those parts are located. So SolidWorks has a built-in feature called Pack and Go. Just go File, within Assembly, click File, Pack and Go. Brings up this toolbar here. So it gives you all the different parts outlined there for you. It shows you where they're located too. And then you have two different options here. So you can either save to a folder or save to a zip file. It'll zip everything together. And that's super handy for sending it off to somebody else. Up here also you have a couple options, including drawings, any drawings that you made of this part. So if I had made made an assembly drawing that detailed all the parts and a bill of materials on there as well, I can include that in for this person to take a look at. Simulation results if I'm doing that. Toolbox Components, which we haven't talked about yet. I think we're talking about that in 2 weeks. So we'll talk about those. But it's basically just built-in bolts, nuts, and washers and stuff like that SolidWorks has. Suppress components, decals, and all that kind of stuff. And then it kind of shows me, all right, here's this assembly. Within that assembly, there's these parts. Within that, there's also sub-assembly with these other parts. Going through, take a quick peek. All right, everything's there that I want to be there. Let's go into a zip file, browse where I want to put it. Cool, that's what it's going to save it as. And add prefixes and suffixes as well, if that helps me out. And then, a couple of options for the folder structure as well. So like I said, if this is all scattered out throughout my drive, I might not want to keep all that file structure, so they can see like, oh, hey, he has a downloads folder, and here's this funny name on this other folder that it's sub-nested in or whatever else. Flatten the minimal folders, or you can keep the full folder structure. Flatten a single folder is usually the best bet for Pack and Go. It puts all the parts in the same folder. That way it's all together. And it changes all the relations as well, so it makes it super easy for them to take a look and see, okay, cool, I have all the parts in here. But if you have a neat folder structure, then you can always keep that full folder structure or maybe minimal folders so that it doesn't go through and kind of recursively add in subfolders. Cool. And then go ahead and cool, save that. If I go to that folder here, I think that's within. Cool, so if I open this up, this is where I saved it. See, all those parts are collected together. It's got all the different parts, and then the assembly is in there as well. So, cool. I think other than that, we talked about drawing, model views, section views, dimensions, bills of materials. So we're pretty set. If you guys want parts to model, let me know. I'll give you some simple stuff. If you want something more challenging, I can give you that as well. And then next week, we're going to be talking about weldments and surfacing. So surfacing is a fairly complicated subject. We'll talk a lot about it. And we won't. I'll try and kind of maybe bring up my steering wheel example again, kind of show you some stuff with that. And then weldments is a super handy one for building chassis. It lets you build a bunch of tubes together with very, very minimal sketching and kind of creating each individual part. Kind of does a lot of the work for you, which is really, really nice. So yeah, that's what we'll be talking about next week. And then I'm glad we finally figured out that sweep thing. It was bugging me all of last week. All right, cool. That's all.